Hello, everyone. A very warm good evening to all of you, and welcome to Unacademy. Welcome to another session in our NCERT series where we are covering the entirety of the fundamentals of physical geography. And I hope that we have been able to catch up and we have been able to revise the previous sessions because these sessions are as detailed as required and talking about the fundamentals in a different manner because NCRTs they are quite boring or regular so to say. So with the help of the images we tend to simplify it. Now in the last session we had been discussing about solar radiation, heat balance and temperature. We had ended our discussion with the heating of land and water, whereby the discussion that the land tends to gain heat at a faster pace, at the same time, tends to lose heat much faster. As a consequence, the implication of which being that during daytime, which will be warmer, land or water, during daytime, it will always be the case of land being warmer, isn't it? Because land gains heat much faster as compared to the water bodies, whereas water is cooler during the daytime. Now, what about night? During night, which will be warmer? During night, because land will lose heat at a much faster pace, it will become colder. Water will be comparatively warmer. So, land will be colder, isn't it? Now, the implication also goes ahead that when we talk about the summer season, during summer, which will be warmer? Always land is warmer. Why? Because you have a larger period of accumulated heat. Whereas during winters, land is colder because for a longer period of time, it will lose heat. Isn't it? This is where we had closed the discussion in the last class. Now, from the last session, we have multiple questions which keep on being asked in the prelims examination. So, first of all, we are going to discuss those PYQs. Okay. Let us see if we are able to solve these PYQs. I hope that we have benefited from the discussion of on the special class on Saturday that we had the MCQ discussion. This is the PYQ discussion, the previous year questions which have been asked from this particular topic. I want you to take a look into these PYQs and I want you to think about it whether it is solvable or not, just after knowing these basic concepts. So, first of all, before we move into that, an announcement for all of you that we have come up with the biggest offer in terms of the product for civil services when it comes to a comprehensive program for your preparation, whereby you will be able to prepare, you will be guided by the best educators in English medium across the country, and you have a lucrative price of 16,999 for 12 months plus a free extension. You have to use the code IES English. The price is going to be hiked very soon. So that is where the offer ends tomorrow. Use that and avail the discount. Now, coming to the PYQ, the first question. Consider the following statements. Thickness of troposphere at equator is much greater as compared to poles. At the equator, heat is transported to greater heights by strong convection currents. Now, here, option A, both statement 1 and 2 are correct, and statement 2 explains the statement 1. B, both statement 1 and 2 are correct, but statement 2 does not explain statement 1. Statement 1 is incorrect, but statement 2 is incorrect, and so on. Let me know what the answer is. So, first statement, that is, thickness of troposphere at equator is much greater as compared to the region of the poles. This is going to be a correct statement, right? Now, then after that, statement 2, at the equator, heat is transported to greater heights by strong convection currents. This is also correct. You have rising air at the region of equator because of the heat which is gained. So that is why both statement 1 and 2 are correct. And statement 2 is the one which justifies the statement 1. So that is where the correct answer is going to be A. Right? Now, a question in 2024. With reference to water vapor, which of the following statements is or are correct? It is a gas, the amount of which decreases with altitude. Its percentage is maximum at the region of the poles. So here, which of them are correct? Okay. When you are solving these questions in the examination or even in test, please ensure that you have maximum focus on whether correct or incorrect is being asked. That can create a lot of silly mistakes out there. Okay. So here basically the first statement that it is a gas is correct. And water vapor, the density is going to be maximum at the region of the ground surface. And as you move higher up, the overall density of water vapor, the concentration of water vapor tends to reduce. Its percentage is maximum at the region of the poles. Is this correct? No. Why? Because water vapor is created how? Water vapor is created as a consequence of evaporation, isn't it? So here basically the when the you go at the region of the poles, the temperature is so low that evaporation is almost absent. That is why its percentage is minimum at the region of the poles. So the correct answer in this case is going to be A, that is 1 only. Then here another question from 2024. Consider the following statements. The atmosphere is heated more by incoming solar radiation than by terrestrial radiation. Carbon dioxide and other greenhouse gases in the atmosphere are good absorbers of long wave radiation. Which of them here is correct? Let me know. This is a simple question. I hope we are able to, I hope we will be able to get this correct. Right. So it is a simple question. Why? Because here the first statement in itself is incorrect. When you have the case where the first statement is incorrect, right? Atmosphere is heated more by terrestrial radiation, long wave terrestrial radiation, rather than the incoming solar insolation. So the first statement is incorrect. Second statement, however, is correct, describing about the greenhouse effect. So that is where you have the easy option, that is statement 1 is incorrect, but statement 2 is correct. Okay, so you can see that over the past few years, what is the concentration that UPSC has put on these particular areas, all to be solved by reading the basic NCRTs. You don't need to. Now people even today were asking me which is the book of geography which will help me clear the exam. Always understand NCRT is the most standard book out there, right? Forget every other book. For general studies, if you read NCRT in greater detail, each and every sentence has a concept hidden. You will be able to clear the prelims easily. Now, consider the following statements. This was a question last year, 2025. Without the atmosphere, the temperature would be well below freezing point everywhere on the Earth's surface. Heat absorbed and trapped by the atmosphere maintains our planet's average temperature. Atmosphere's gases, like carbon dioxide, are particularly good at absorbing and trapping radiation. Which of them are correct? Now, this is where UPSC has given a wrong answer as per the NOAA website, as per the Meteorological Department's website, and even if you apply logic. Okay. So, here, basically, UPSC has given the answer as D. Okay, which is incorrect. UPSC has given the answer as C. My bad. UPSC has given the answer C, which is incorrect. Right? Now here, the first sentence, without the atmosphere, temperature would be well below freezing point everywhere on the Earth's surface. This is an absolute statement. please understand, had there been a mention of average temperature is below freezing point, it would have been correct. But there is no average temperature which is mentioned. It is mentioned everywhere. Now, it for the side which is facing the sun, temperature will be higher than freezing point. What is the evidence for that? If you take a look at the surface of Mars, Mars is far away from the region of Earth. Distance from the sun of Mars is greater than the distance of Earth from the sun. Now, even on the Martian surface, the daytime temperature at the lower latitudes is higher than zero. So, definitely for the Earth, at some point during the day, the temperature will breach zero and will be high. But average temperature will be definitely below the freezing point. That is why one, as per the meteorological services, etc., is considered to be incorrect, but UPSC has considered it to be the correct answer. Heat absorbed and trapped by the atmosphere maintains our planet's average temperature, the greenhouse effect. Atmosphere's gases like carbon dioxide are particularly good at absorbing and trapping radiation. This is again correct. So, ideally, the correct answer should be D, but UPSC had given the answer as C. Now, which of the following? So, this is basically a question associated with isotherms. We will be discussing after the discussion of the isotherms. Consider the following statements. The temperature contrast between continents and oceans is greater during the summer than in winter. The specific heat of water is more than that of the land surface. So, here, what will be the correct answer? Think about it carefully. So, basically, in this, when you take a look at the first statement, right, temperature contrast, that is the difference of temperature. It will always be higher in the winter months, not in the summer months. Why? Because during summer months, water will be around 24, 25 degrees Celsius. And if you go to the mid latitudes, then or 23 degree, 20 degree, land will also be around somewhere 25, 26 degrees Celsius. During winter, land can breach freezing point temperatures. Water will still maintain its heat level. So that is where the greater temperature contrast is during winter and not during summer. So the first statement is incorrect, which renders only one option as a possible alternative, that is D. Okay. Now, again, another question which was asked from this annual range of temperature in the interior of the continents is high as compared to coastal areas. What is or are the reasons for this? Thermal difference between land and water, variation in altitude between continents and oceans, presence of strong winds in the interior, heavy rains in the interior as compared to the coasts. Again, a question about the temperature difference in the coastal area as compared to the interior area. Remember, we had discussed in the last class on Friday that the temperature extremities in the interior are much higher, right? Summers are much warmer, winters are much colder. Whereas in coastal area, you have a moderation of temperature, moderate temperature which is experienced. We had taken the example of Delhi and Mumbai in this particular case. So here, basically, thermal difference between land and water. This is correct, which ends up ensuring a moderation of temperature. Variation in altitude between the continents and oceans. Even if in the interior area any region is at sea level, still it will have extremity of temperature. So altitude is not the prime factor which is controlling the temperature variation in the coastal area and the continental area. So the second option is absolutely incorrect. Now, if you figure out that the second option is incorrect, you can figure out the answer easily. The correct answer in this case is going to be A, that is one only. Okay. And after today's discussion, we will be discussing a couple of other PYQs as well. So we start the discussion from where we left off. And we left off after discussion of the temperature difference in the land and the water, the heating and the cooling. Now we come to the case of isotherms. What do we understand by isotherms? Iso means similar, therm indicating temperature. So iso means similar, therms mean temperature. Okay. So these are basically imaginary lines which end up joining places indicating similar or same temperature. Okay. So for example, if let's suppose you have two distinct places A or many distinct places A, B, C, D, right? And let's suppose you also consider E. Now, A is indicating, let's suppose, 30 degrees Celsius. B is indicating 30 degrees Celsius. C as well as indicating 30 degrees Celsius. Okay. D is indicating 32 degrees Celsius. E is again indicating 30 degrees Celsius. So the isotherm will basically be a line like this. This will also be referred to as the 30-degree isotherm. The 30-degree isotherm. Okay. That means all the places that it will join will be the places having 30 degrees Celsius. So automatically you can come to a conclusion that any place which lies on 30 degrees Celsius isotherm would have had a temperature of 30 degrees Celsius. Now, why are the isotherms used? Isotherms are used in order to indicate distribution and variation of temperature. That is why you basically end up using these isotherms. How the temperature distribution does happen across various different parts of the planet. The variation between day and night, variation during summers and winters, everything can be explained with the help of the isothermal image. Okay. Now, if I ask you a basic question, if I have an isotherm, can I have another isotherm which will crisscross it in the map? Can I have that? Can two isotherms crisscross each other? What do you think? The answer is no. Why? Because whenever you talk about isotherms, okay, they will be indicating a particular temperature. Let's suppose this is a 30 degree Celsius isotherm. This is a 32 degree Celsius isotherm. So that means all places on this isotherm will be 32 degrees Celsius. All places on this isotherm will be 30 degrees Celsius. Right? What about this place? Will the temperature be 30 or 32? It cannot be. Any place cannot have the same temp at the same time, cannot indicate two temperatures, isn't it? At one point of time, any place will have only one temperature. So that is why isotherms never crisscross each other. Okay? They never tend to crisscross each other. Remember that. Okay? Now, here basically what you see is the thermal image. Temperature, how it varies in the month of January. Now, in the month of January, northern hemisphere will be experiencing winter months and southern hemisphere will be experiencing summer months, isn't it? Because in the month of January, it is the southern hemisphere which is tilted towards the sun, and you basically will have the northern hemisphere which appears to be tilted away from the sun, right? So that is basically where, if you observe that northern hemisphere is comparatively much colder. Now there are certain extracts that can be taken out from this, certain conclusions can be taken out from this. One, in the southern hemisphere, you will find that the isotherms are generally parallel to each other, vary with latitudes. Whereas in the northern hemisphere, the isotherms are much more distorted. Observe this isothermal map, right? In the southern hemisphere, they are parallel to each other. In the northern hemisphere, they are quite distorted. Why does this happen? Very simple. Because southern hemisphere is an oceanic hemisphere dominated by oceans always. So here in the ocean, temperature does not change drastically. The specific heat is higher, so it takes time to change the temperature. So temperature has got much gradual change. That is why isotherms are parallel to each other, almost parallel to the case of the latitudes. Whereas in the northern hemisphere, observe this. The isotherms, they bend polewards or equatorwards. Now, if you observe this, it will further validate our study of the temperature of land and oceans, heating of land and oceans. Now, let's suppose I draw a particular latitude here. I hope this latitude is visible to all of you. Right. Now, let me consider different places on this latitude. Let me consider the place A, the place B, the place C. Now, temperature at A, I can get it by looking at the isotherm which passes through A. So, what will be the temperature at A? Temperature at A will be here, which is the isotherm which is passing through A. It is minus 25 degrees Celsius. Okay. Temperature at B, indicated by the isotherm which passes through there, that is the 0 degree C isotherm. So, at B, temperature is 0 degrees Celsius. Then temperature at C, the isotherm which passes through C, which is that minus 12.5. So, what can I extract from it? That during winter, at the same latitude, at the same latitude, land is much colder, much colder. That is what we got with the thermal image also. That at the same latitude, the land is much colder, water is comparatively warmer, right? So, land is much colder and water is comparatively warmer. Oceans are warmer. Now, that is why you observe this isothermal bending. So, here, if let's suppose you consider this minus 12.5 or minus 25, any of these isotherms. Now, when this isotherm is crossing over from land to ocean, in order to reach or experience minus 12.5 degrees Celsius over oceans, you have to move closer to the poles. That is when the lower temperature will be experienced. That is why the isotherms bend polewards while crossing from land to oceans, right? And they move equatorwards because this minus 12.5 degrees Celsius can be experienced at much lower latitude over land areas. So, this gives me a behavior of isotherms during winter. That is, while crossing from continent to ocean, isotherms bend polewards, right? And basically, while crossing from ocean to continent, ocean to continent, isotherms bend equatorwards. Isn't it? That is basically why. Why does this happen? Because of this phenomenon. Land is much colder and water is comparatively warmer. Okay. Based on this consecutive years 2023, 2024, you had the prelims question asked directly from this particular conclusion of ours. Now, when you talk about the summer season, in the month of July, northern hemisphere will experience summer, whereas southern hemisphere will experience winter. So here, if you observe the trend, land areas are much hotter, water is comparatively colder, right? Because summer, the temperature increases over the case of land areas, accumulation of heat. So the isotherms in this case will bend equatorwards while crossing from continent to ocean and vice versa while crossing from oceans to continents. That is why you observe this trend. Okay? So that is why the behavior of isotherms during summer, during summer, you will have land is much hotter as compared to oceans. Okay. So that is why, hence, isotherms bend equatorwards while crossing from continent to land. Okay. Continent to land. Right. That is the case of the isothermal behavior, how the isotherms tends to behave. I hope this is clear for everyone. Now, this is the map that and the NCERT has given for the isothermal distribution during the various months of July, January, etc. Now, here, NCERT, as I told you, continent to ocean, right? Correct. Ocean. Yes, correct. Now, in this case, as we had discussed, that basically NCERT has simply mentioned inversion of temperature in this extent. But in reality, this has got much greater depth associated. We will cover it in depth so that this should be your comprehensive coverage and you should not look for other sources here. Okay. So, what is the case of temperature inversion? Under normal circumstances, what do we experience? The air which is closest to the ground surface is going to be warmer because it is being heated by conduction, terrestrial radiation of planet Earth, etc. And as you move higher up, the temperature tends to reduce. This is what we refer to as the case of the positive lapse rate. Positive lapse rate, isn't it? Now, what happens when the warm air is at the bottom and cold air is at the top? Cold air is always going to be heavy. Warm air is always going to be light. Okay. So warm air tends to rise up, whereas cold air tends to sink. So there is a kind of a circulation, a mixing of air happens. This is known as the unstable air. Unstable air. Whereas when you consider the condition of inversion, due to certain climatic conditions, due to certain climatic factors, sometimes what happens is that you have the surface, the air closest to the surface, that becomes very cold, and the air above becomes warm, right? So you have the warm air which is trapped. Now, in this case, warm air is already on top. It cannot rise further. Cold air is already at the bottom. It cannot sink further. So, in this case, you will observe no vertical mixing of air. No vertical mixing of air. This is what is referred to as the condition of stable air. This is what is the reverse of the normal conditions. So, when you have a situation where the air basically, the temperature change with altitude reverts from normalcy, that is known as inversion of temperature. Under this condition, what will happen? No mixing of air. If let's suppose you have emission of smoke or anything, let's suppose you have set up a factory here, there is emission of smoke, most of that will be restricted here itself because you have cold air. So pollution tends to get exaggerated. This is what happens in the region of Delhi NCR and the northern plains of India during the winter months. You have such cold air near the ground surface that basically you don't have any mixing of air. So the pollution problem appears to get much exaggerated during the winter months in North India as compared to the summer months. That is the case of temperature inversion. Now, when we say temperature inversion is of different types. Okay, you have the case what is known as surface inversion. It is basically because of why this process of inversion has happened. That is how you classify this case of temperature inversion. Why the inversion has taken place. Okay, so here, what is one is known as the surface inversion, another is known as the upper air. So both of these are known as together upper air inversion, which happens at greater altitude. So this is your upper air inversion. So you have the case of upper air thermal inversion as well as the case of upper air subsidence inversion. This is also what is referred to as mechanical inversion. Why? Because it leads to, or it is caused because of the movement of winds. That is why it is referred to as mechanical inversion. Movement of winds. Okay. This is not mentioned even in many of your reference books, but I want you to have this understanding because it will improve your answer writing, etc. UPSC had asked a mains question: what is inversion of temperature? In that case, only this short paragraph, if you will write, you will get a big 0 or 1. You will get binary digit score. That is something I am sure you are not targeting for the mains examination. So that is why the more details you provide with the help of the images, better it is for your scoring ability as well. Then you have something which is known as frontal inversion as well as valley inversion. Now, in India, you experience surface inversion, you experience valley inversion. These are the only two categories that you experience in countries like India. Okay. Whereas in higher latitudes, in mid latitudes, you will basically experience almost all these kinds of inversions. So, what are these? Let us understand them. Starting first of all with the case of the surface inversion. Let us assume a city like Delhi during the winter months. Now, during the winter months, in the afternoon time, let's suppose at around 2 p.m. Now, the ground temperature is how much? Let's assume around 14 degrees Celsius. Okay. Air temperature will also be around 14 degrees Celsius. Now, above it, the air gets cooler. Let's suppose it gets to 8 degrees Celsius. Above it, the air gets further cooler. Let's suppose it is 2 degrees Celsius. Right. Now, day is the time when the surface gains heat. Night is the time when the surface loses heat. So when it gains heat, this is the temperature during daytime. During night, after sunset, the surface continues to lose heat by what? Long wave terrestrial radiation. Okay. So that is where the surface continues to lose heat. Now, let's suppose you consider the time at 4 a.m. in the morning when it is very, very cold. At 4 a.m. in the morning, the ground temperature will dip maybe to 2 degrees Celsius. Now, the air which is in contact with the ground surface will also cool down, will also indicate a temperature of, let's suppose, the 2 degrees Celsius. Now, above it, this air will also cool down, but not at the same rate. Why? Because it is not in contact, it is not touching the ground surface. Surface air has cooled down because it is touching the ground surface. At this altitude, it is not touching the ground surface. So, what was 8 degrees Celsius in the afternoon, let's suppose becomes 3 degrees Celsius at night. Temperature has dipped. Above it, let's suppose from 2 degree, it has reduced to minus 4 degrees Celsius. Right? So, everywhere the temperature is dropping as compared to the afternoon. But at the surface, the temperature is dropping most drastically. Why? Because the surface has become so cold, and by virtue, it is cooling down the air above. That is why you refer to this as the surface inversion. Why? Because you have a 3 degrees Celsius air above the 2 degrees Celsius temperature air. Okay, so that is basically the case of temperature inversion experienced during winter nights. Winter nights. However, in the region of the poles, in the polar areas, this phenomena is experienced almost all throughout the year. Throughout the year. Why? Because in the region of the poles, you basically have extreme cooling of the ground surface. Always. That is why surface inversion is common in the region of the poles. Then you have the case of mechanical inversion, subsidence inversion. So this is not something which is experienced in India. Let's suppose you consider the region of 40-degree north, 50-degree north, what is referred to as the region of mid latitudes. Mid latitudes. That is around 30-degree, 40-degree, 50-degree, 60-degree north. So let's suppose you consider, so mid latitude is generally 35-degree to around 60-degree north or south. That is the region considered to be mid latitude. In mid latitude, let's suppose winter. In the winter, ground will be very cold. Ground is very cold, isn't it? Now, if the ground is very cold, then what happens? So basically, the ground is cold, the air above it will also be cold, isn't it? In that aspect, or in that regards, or during this scenario, let's assume there is, due to some upper air climatic conditions, there is the air which sinks, which starts to sink. Now think about it. This is a parcel of air which is sinking from above. Now, as it is sinking from above, it is moving into the region closer to the ground. It will be forced to compress. Why? Because density of air closer to the ground is much higher. Density of air at a greater altitude is much lower. So when it is forced to sink, it will tend to compress itself. Right? Now, what happens when something is compressed? It heats up. Any object, if it is compressed, it tends to gather lot of heat. So the air which is sinking tends to heat up. This is what is known as adiabatic heating. That is what is referred to as adiabatic heating. What is adiabatic heating? Heating of air just by compression. Adiabatic cooling, cooling of air just by expansion. So that is adiabatic. Simple concept. Any object that you take, if you compress it, it will get heated up. If you expand it, it will cool down. So here the air is being compressed as it is sinking closer to the ground, it will heat up. Now, when it heats up, then what happens? In case it gets cooler, then it gets warmer than the ground air. Inversion takes place. But this inversion has happened. Why? Because of the process of sinking of air. That is why this inversion has happened. That is what is referred to as the case of subsidence inversion or the case of mechanical inversion. Why? Because the mechanical movement of air has caused this kind of heating action to take place. Okay. Now, this is experienced in mid latitudes, particularly during winter. You had the very infamous case in London in 1952. And in fact, in the 1950s, when you had, talk about the smog which happened in London. Now, in London, what happened? That during those days, you did not have so much of gas connection, etc. So everybody was using coal and fossil fuel to keep themselves warm. So household cooking, etc., in many of the suburbs would be done by coal. Now, during those days, London had a case of a sinking air for a brief duration. Mind you, everywhere sinking air might not create this inversion, but sometimes when the sink is so much and the compression is so much that it creates a warm layer. So that is when London experienced the subsidence inversion. As a consequence of that, what happened? The vertical mixing of air stopped because you had a layer of warmer air above. So all the smoke from London accumulated close to the surface only. It could not mix. That created poisonous carbon monoxide to dominate the air. 100, more than 100 people are said to have lost their life. Hundreds were taken ill and suffered and had to be taken to hospitals, right? So as a consequence of that, London smog is still one of the greater disasters post Second World War in the region of London, right? So that is basically, again, a geographical phenomena which had created this disaster. Okay. Then you have what is known as the upper air thermal inversion. This is not mechanical, just this is natural thermal. So we have seen in the layers of atmosphere chapter that basically in the troposphere, as you move higher up, the temperature tends to reduce. By the time that you reach the top of troposphere, maybe the temperature reduces to minus 60, minus 70 degrees Celsius. As you move into the stratosphere, due to the presence of ozone layer, there is heating which takes place. So here, top of troposphere is a region of cold air. Above it, stratosphere is warmer. So that is a natural cause of inversion which is present everywhere across the planet. This is one of the reasons what prevents the mixing of air between troposphere to stratosphere. So this is the reason why air circulation in troposphere does not reach stratosphere. Okay, right? Then after that, you have the case what is known as valley inversion. What is this valley inversion? It occurs in the mountain valleys during night. So what is this case of valley inversion? So basically during night time, you have very cold air on top of mountains. Mountain tops get very cold during night time, whereas valley is comparatively warmer. So this cold air being heavier starts sinking, starts to sink because cold air is heavier. It starts moving like a drain. This is what is also referred to as the air drainage. Okay. So as it starts to sink, it uplifts the warm air from the valley bottom and colder air replaces it. This causes inversion of air even in the region of these valley bottoms. Okay, so that is the case of valley inversion, due to which always it is advisable that in narrow valleys where you have steep sided mountains on the sides, never to take shelter at the valley bottom during night, because it can get very cold at night. That is why you will find when you go to the mountains, let's suppose for trek, etc., you will find that even the settlements, the villages, they are located closer to the sloping areas. Right? Why? For two reasons. Valley can get flooded during the night, first of all, and secondly, it gets very cold at the valley bottom during night. Not in Western Ghats so much, because Western Ghats they don't have that much height, but in the region of Himalayas, in the region of Alps, etc. Warm air always, Vinita, has a tendency to rise up because warm air is lighter. Cold air is always going to be heavier. So cold air has a tendency to sink. Warm air always has got a tendency to rise up. That is the general tendency. Then you have something which is known as a frontal inversion. What is a front? So when you have conditions where you have, let's suppose, if you consider the planet, let's suppose here you have the region of the poles. Here, let's suppose you have the region of 30° north. Okay. Now, cold polar air will come here, warm tropical air will come to the region of the poles. Now, polar air is very cold, reduced volume, it maintains its volume almost in a compressed state. Warm air, on the other hand, is much more expansive. Warm air is lighter, so you'll find this is the case of warm air, this is the case of the cold air. Now, your normal logic will tell you warm air and cold air come, they mix with each other, they meet, and life goes on happily thereafter. But in reality, it does not happen. Warm air and cold air do not mix very readily, and especially when they cover very large areas. They do not mix, right? So, in this particular case, let's suppose the cold air starts to move, it will maintain its volume, and this cold air will enter and penetrate into the region of the warm air. This cold air will penetrate further, and what you will have is that the warm air is lifted upwards. Okay, this also creates an inversion. This inversion is known as frontal inversion. Why frontal inversion? Why frontal inversion? Basically, because any place where the warm air and cold air, they meet. This is known as a front. We'll study about the front in later chapters. Why warm air sinks in subsidence inversion? Okay, I think there is a doubt in the concept, right? Please understand here, it is not the case that the warm air is sinking here. No, please understand this. It is the case whereby you will find that cold air is sinking, warm air is not sinking. So, what happens in this case? You have the sinking of cold air, right? Sinking of cold air. Now, as the sinking of cold air does occur, cold air comes closer to the ground, right? Now, please understand this, that when we talk about the density of air, how closely the air particles are packed, air particles are much closely packed closer to the ground surface as compared to higher up. Higher up, the density is less. So, if there is an air parcel which is sinking, when it comes to the region of greater density, it has to compress itself. For example, let's take the train example. Now, when you ride a train, right? A crowded train. Now, in order to board that crowded train, what do? You try to compress yourself, you try to squeeze through, right? So you are trying to reduce your volume as compared to normal. But if you are standing in an empty train, then you won't stand like this, then you will stand normally. So what have you done? When you have tried to go into the region where the density is high, you have compressed yourself, isn't it? So similarly, when the air comes closer to the ground, it is coming to the region of higher air density, isn't it? As a consequence of that, compression of air occurs. Air gets compressed. Now, anything which gets compressed, let's suppose I take the case of this pen. If I compress it, what will happen? It will get heated up and then it will break, right? So, any compression creates heat. Creates heat. Remember, we talked about the case of planet Earth's interior being heated, one of the reasons being the compressional heat. So, compression always leads to the heating. So, that is where, when it creates heat, you have warm air parcel which gets created, and this causes inversion. Okay, the moment a layer of warm air is created, no further sink will happen. Warm air will never sink into the region of cold air. Never. Okay, it will never sink into the region of cold air. It can never happen. Okay, so always sinking will happen as long as the above air is cold. But as it starts to sink, there is it gets compressed and it warms adiabatically. I hope that is understood. Okay, now then, moving over to the next chapter, we initiate this chapter. We will not have the complete discussion of this chapter today. This is the chapter associated with atmospheric pressure, the case of the wind systems, permanent wind systems, etc. Now, today, we are just going to discuss the basics of atmospheric pressure. We are going to discuss about what creates wind. Okay. So, basically, when we talk about pressure, what is pressure? So, the weight that the air extends or subtends to the ground surface, that is known as pressure. Okay. So, pressure is the overlying weight. For example, let's suppose I take this pen, I push it on my hand. It creates a condition of pressure, isn't it? So, this is the case of pressure. Similarly, on the ground surface, you have the atmospheric pressure. Okay, weight of the overlying layer of air, that is known as atmospheric pressure. Now, normally, what is this pressure? This pressure is expressed in millibar. So, it is 1013.2 millibar. This is the normal atmospheric pressure. Atmospheric pressure. Okay. Now, if a region has got 1020 millibar, it will be considered a region of high pressure. If a region has got 990 millibar, it will be considered a region of low pressure. Okay. Now, this is basically the pressure experienced at sea level. Okay. So that is your normal atmospheric pressure experienced at the region of the sea level, 1013.2 millibar. Now, what is this pressure once again? Weight of the air extending on the ground surface. That is the case of the pressure. Okay. Now, what if I move up in height? I move to the top of the mountains. Then what? So basically, if you consider that, then near the sea level, there will be greater amount of air weight which will be imposed. As you move slightly higher up, lesser weight will be imposed. As you move higher up, even lesser weight will be imposed. So, can I say that as you move higher up, the pressure tends to reduce? Pressure reduces with altitude. Okay, altitude. Always. Okay. Even at the same level on the ground surface, pressure does vary from one region to another. Atmospheric pressure, let's suppose in a Mumbai, will be very different from atmospheric pressure in a region like Delhi. Due to multiple different factors, the pressure tends to vary. Okay. Now, you have the case of isobars. Isobars, just like isotherms, are imaginary lines. These are basically imaginary lines joining places of equal pressure. Joining places of equal pressure. Okay. So if I have A, B, C, D, E. Now, if A is indicating 1010 millibar, B is also indicating 1010 millibar, C is indicating, let's suppose, 995 millibar, D is indicating 1015 millibar, E is indicating 1010 millibar. So the isobar will be basically the case of A, B, and E. This isobar will be 1010 millibar isobar. Here, iso represents similar, similar, bar represents pressure. So line joining places of similar pressure. Okay. So if you take a look at the isobaric representation, observe the case of the representation over India. You will observe the various different isobaric lines. For example, 1010, 1009, 1008, 1007. So you will observe that here, basically, by the time that you reach the region around Jammu Kashmir, Chandigarh, Delhi, it is 998 millibar. Okay. So here, each of them indicate a different pressure condition. So pressure varies from one region to another based on temperature, based upon the case of rising air, sinking air, mountain presence, many of the things. The pressure will tend to vary. Okay. Now, how the pressure varies, that also becomes important. Right. So, for example, if I consider two different places, A, or let me consider the region between Delhi to Kolkata. Kolkata. Think about it carefully. Apply the rare commodity that you have, that is your logic. Okay. And Delhi to Mumbai. Out of these two, where do you think that the pressure will change very drastically? Out of these two, where do you think the pressure is changing much more drastically? Delhi to Kolkata or Delhi to Mumbai? Out of these two places, you will find that basically while you are moving from Delhi to Kolkata, the pressure is changing by 1 millibar, isn't it? Whereas while you are moving from Delhi to Mumbai, the pressure is changing by almost 6 millibar. right? Isn't it? Is it lower in Jammu Kashmir due to high latitude comparatively? No, it is associated with the case of the heating of the land. Wherever there is greater heat, generally is associated with the lower pressure, right? It is the month of July that is indicated in this particular map. So, July is the month of increased amount of heat. Okay, correct. Avantika. Line is not straight because pressure is not uniform. Just like temperature is not uniform, so pressure is also not going to be uniform. Okay, we will discuss about the case of the pressure also, that there is a thermal pressure, there is something known as the dynamic pressure. We will discuss about that also. But today, we just take the case of the generic example. Okay. Now, in this particular case, you will observe that the difference of pressure, duration, the lower pressure, this lower pressure is responsible for monsoon too. Yes, correct. The movement of winds, etc., does happen because of that. Now, when I tell you that there is a region which has got high pressure and there is a region which has got low pressure, so that means in the region of a high pressure, I will have more number of particles. All those particles are subtending and extending their weight on this, isn't it? Won't higher temperature mean more air mass? No, no. Higher temperature basically will always mean the case of lower air mass. Okay. Let me tell you the reason behind it. Okay. Let me talk about that concept first, then I will come here. So, okay. Let me use this particular slide. Okay. Consider this. I have two air parcels. Okay. In this case, I have the particles, right? Two air parcels. Same air parcel, let's suppose of the same volume. Same volume. Okay. Now, let's suppose I heat the first one. I take this temperature to 35 degrees Celsius. Now, heat is what? Heat is a form of energy, always, isn't it? Heat is a form of energy. So, whenever anything gets heated up, means it gets more energy. So, here, the individual particles will get more energy. In this first instance, A, individual particles will get more energy. When they get more energy, means what? They will start running around. When you were kids, whenever you had some energy, what would you do? You would start running around. You would go around, run here, there, play, and kept on playing as long as you had energy. So, here also, the molecules will gain energy. They will try to move. Can I have a situation where some of these molecules will escape the system, will move out of here because now they have energy? So, as they have energy, they have escaped this. So, as compared to earlier situation, this heated air will get lighter or will it get heavier? What do you think? Heated air in this particular situation will get lighter. Why? Because the other molecules have escaped the system, isn't it? So, heated air gets lighter. Now, when the heated air gets lighter, means what? Anything which is lighter than the surrounding, it will tend to rise up always because it is lighter. So it will have a tendency to rise up, isn't it? So that is why heating of air creates a rising air column. Correct, Aditya. That is what is referred to as the thermohaline circulation. We will, if the scope is there, we will cover that in the case of oceanography. Okay, this is understood. Now, if I have the ground surface, now this was the air. This air starts to rise up. Now, what will happen to the pressure being exerted on the ground surface if this air rises up? The pressure on the ground surface immediately will reduce, isn't it? Earlier, this was the air. Now it has started to rise up. Means on the ground surface, the pressure has reduced. So, this rising air column, wherever you have a rising air column, always creates a condition of low pressure. Correct? Now, let's suppose I have another air parcel that is B. Now, B, I have reduced the temperature. I have kept it to 2 degrees Celsius. Cooling. Now, we had discussed about it that cooling is not a form of energy on its own, right? You cannot artificially cool something unless and until you are a Marvel superhero and you can basically throw ice out of your fingers and your eyes. You cannot cool anything out. So, how do you cool something? By extracting heat out of it? Always. How does your refrigerator cool any object? It extracts the heat out of that object. How is it that your room gets cooled by the air conditioner? The heat is extracted of the room becomes colder, right? No, Vinita, the entire air column in itself warms up. So the entire air column in a region will rise up. So think about it. If this is getting heated, if you provide heating here, this entire air column gets heated up. That is when it will rise up. It will create, remember, we had discussed about convection. How does convection happen? So, in that case, if you have not attended the previous session, just look at this. When you basically boil something on a teapot, or basically you boil water on in a pan, what happens in that case? Whenever you boil water in a case of a pan or a utensil, what happens in that case? In that case, the heating is provided at the bottom, isn't it? Here, the bubbles get created. The bubbles are lighter, they rise up, whereas the colder water sinks. That is what creates a convection. Now remember, the heating of atmosphere happens first by conduction from the ground surface, then the air rises up and transmits it through convection. So here also the air becomes lighter, it displaces the surrounding air and it rises up. So the air will rise as long as it is warmer than its surroundings. Till that point of time, the air will continue to rise up. Okay. Now, when we talk about the colder air means what? That you have extracted the heat energy out of it. That is why it has become cold. Again, remember your childhood days. Whenever somebody would have extracted energy out of you, or when you would have spent all your energy, what would you do? You would slump to your bed and you would sleep, right? Or you would sit down somewhere tired. So when the particles also, they have the energy which is extracted, then what happens? In that case, they lose the energy. So cooling means loss of energy. So the other particles nearby, so they simply slump towards each other. They get accumulated towards each other. From the surrounding region also, the particles fall in because they don't have energy. They are attracted by each other. And eventually, what happens as a consequence of this, you will have more number of particles as compared to earlier. So that is why colder air is heavier. Always. Always you will have the case that the colder air is heavier. Okay? Correct, Aditya. So, for example, this was the air. Now, more particles have come here. That means what? It will increase the pressure, right? So, colder air is heavier, it tends to sink. Anything which is heavier tends to sink. And whenever it sinks, it will create high pressure. So, colder regions will have sinking air, warmer regions will have rising air. Okay, so that is basically why in the region which is slightly colder, generally you will have the condition of high pressure. In the region which is warmer, you will generally have the condition of low pressure. Okay, so wherever you have warmer air means what? Comparatively less number of particles are there, it is lighter, many particles would have escaped. Wherever you have colder air, more particles are there, sinking action. Okay, that is how the pressure changes from one region to another, right? Now, here basically the now think about it, where I want you to first of all look into this image. If I consider this place A and I compare it with this place B, A has got abundance of particles, whereas B has got absolute lack of particles. So there is a net movement of particles which will happen from A to B, from surplus to deficient. Why? Why will this movement happen? Because we have just talked about it, that wherever the conditions are colder, there is heavier air, so the air tends to sink. Wherever there is heating, there is warmer air, tends to rise, right? So from here, the air will tend to move. This is what is referred to as a wind. So wind always moves from a high pressure to a low pressure area, or from a region of surplus to a region of deficiency. That is why next time when you stand up into your terrace or in your balcony and you face certain winds, always understand that it is going to a region of low pressure. Okay. Wind will always blow from a high to a low. But when you experience winds, you would have experienced that winds oftentimes change their, sometimes they are stronger, sometimes they are weaker, sometimes they change their directions, and so on, isn't it? So basically, when we talk about the case of the winds, winds are dependent on certain factors. What are those factors? You have three major factors: the pressure gradient force, Coriolis force, as well as the frictional force. These are the three factors which impact the wind movement. Okay. What are these? First of all, the pressure gradient force. What is pressure gradient? Pressure gradient is how does the pressure change from high pressure to low pressure? Okay. How does it change from a condition of a high pressure to a condition of a low pressure? Okay. So that is basically where you will observe that in regions of high pressure, you have more number of particles. In regions of low pressure, you have lesser number of particles. Okay. Now, from the region of abundance to the region of deficiency, the particles will move. Just like water. Water moves from what? From a greater height to a lower height. They will never move from the same height. Similarly, winds also, or the air particles also move from a region of surplus to the region of deficiency. This movement of particles is what we refer to as the case of winds. Okay, so that is basically the case of wind movement. So, wind movement always does happen with the case of the surplus to deficiency. This is what can also be expressed with the placement of isobars. So, wherever you have the high pressure to the low pressure. Now, whatever is the difference between the high pressure and low pressure, so will be the strength of the wind movement. Just like water, as I told you. For example, if you keep a water column, or if you have, let's suppose, a container at a height which is, let's suppose, from the top of the table, you pour water by a glass, right? Now, it will cover some height. But if you go to the third floor and then you pour that glass of water, water will have a greater force. So, in the case of water, greater the height difference, more stronger is the flow. Similarly, in the case of particles and the wind movement, stronger is the uh, difference of the pressure, stronger is the wind movement. Okay, this is what is known as pressure gradient force. We will cover this and the remaining portions. Tomorrow, we will be also discussing about the air circulation, permanent wind systems, the concept of local winds. That is something that we are going to discuss along with the Coriolis force. What is the case of the Coriolis force? That is again something that we are going to discuss tomorrow. I hope today's session has been understood. Do solve the PYQs. Let me know how many of you have been able to solve all the PYQs correctly in the comment section. And we meet again tomorrow. If you have benefited from these, don't forget to click on the like button, put that in the comment section, and share it with your friends. And by the way, a very important message for you. We are in the very initial stage of climatology right now. In case you are finding any difficulty in understanding this, look at the previous chapter, understand the basics of heating and cooling. And this is where you slowly and steadily we will lay the foundational steps which will help you understand even complicated concepts like cyclones. But for that, you need to have the basic foundation lead. So that is why I'm not having an overdose of information. We are going slowly, we are going steadily. And do let me know if we are able to understand that. Put that in the comment section and we will proceed again further. Take care of yourself. Goodbye and see you tomorrow. Thank you.